Look at this generated video showing a dense, glowing stream of abstract data cascading in perfect alignment. When an AI response pours onto the screen, it feels incredibly reassuring. The grammar is flawless, the formatting is crisp, and the delivery is instantaneous. It looks exactly like a finished, definitive answer. But beneath that polished surface, there is usually a nagging doubt. You read the crisp paragraphs and wonder if the machine is handing you an actual insight or just confidently reciting highly plausible nonsense. When that doubt hits, our natural instinct is to ask the machine for a lifeline. We type something vague, like, "Is this correct?" or "Are there any errors in this?" We do this because we want permission to stop thinking. But leaning on the machine to validate its own work reinforces the initial illusion of certainty. Let's see what happens when you hand a language model a broad, undefined request to simply critique your own answer. The model replies with a list of bland caveats. It calls it a reasonable starting point, but could use additional considerations. It performs self-criticism, offering polite elaboration instead of actual corrections. This process fails because you haven't given the algorithm a specific dimension to look for. Without a target, its training defaults to defending its original output. You aren't actually verifying truth here. You are trapped in a feedback loop. The output looks like rigorous evaluation, but it functions entirely as self-endorsement. To get real answers, you have to abandon the search for validation. Instead, you instruct the model to actively attack its own logic by asking, "What is the strongest objection to this answer?" That specific framing bypasses the programmed off-ramp. You aren't asking for a list of minor reservations. You are explicitly forcing the algorithm to identify the single most powerful counterargument against its own reasoning. This animated diagram of a solid geometric monolith represents the initial confident argument. When you demand the strongest objection, the block cleanly fractures into opposing planes, replacing generic caveats with sharp structural critiques the model knew existed but omitted. The machine clearly has the ability to evaluate its own work, but that analytical depth sits entirely dormant until you provoke it with an adversarial prompt. You can push this even further by targeting the invisible foundation of the text. You do this by asking the model, "What assumptions did this answer make that might be wrong?" Large language models are highly aware of the logical premises their reasoning relies on. They just don't list them automatically. Asking specifically draws those hidden premises out into the open. Look at this heat map applied to a grid of data nodes, visualizing the confidence gradient technique. Instead of asking, "How confident are you?" ask which specific claims the model is least confident about, exposing those volatile cold spots. By isolating the exact points where the reasoning rests on the thinnest evidence, you find the conditions that would cause the entire conclusion to fail. If the answer breaks when a specific variable is true, you now know to go check that specific variable. Targeting specific vulnerabilities hijacks the machine's reasoning engine. This turns the output into a testable hypothesis. But there is a definitive boundary where this technique completely stops working. When it comes to factual errors and hallucinations, like fabricating a citation or inventing a historical event out of thin air, self-critique is entirely useless. We can see this mechanical failure in this perfectly smooth liquid surface, masking the chaotic geometry. The same algorithmic fluency makes the lie perfectly plausible. Because the algorithm literally cannot see its own fabrications, a confidently generated wrong answer will simply be confidently endorsed during the critique phase. This sets the definitive limit of the system. It can reliably detect a gap in its own logic or a missing perspective, but it is completely blind to its own fabrications, and that leads to a subtle, dangerous trap. It is incredibly easy to confuse an elaborate, rigorous-looking self-critique process with actual verification. Watching the model analyze its own work, identify flaws, and rewrite its output creates a highly convincing sense of security. It feels like the core facts have been thoroughly checked by a second set of eyes, but they haven't been. The practical purpose of self-critique is just to expand your own thinking. It is an instrument designed to surface hidden assumptions and unseen risks, not a source of absolute proof. The machine can expose the fractures in its own logic. It can point out where its argument is weakest.